Welcome, 8th grade math. How you guys doing? Hey, we have finished this chapter, okay? We have finished chapter 9 and big ideas. What I'd like to do with you guys today is go over some of these practice test questions, the chapter 9 practice test, okay? So if you want to grab that and go through this with me, I'm not going to do every single question. I'm going to do the majority of them, and then I've shown all my work and answered all the questions and put the answer key to this practice test on Schoology. So again, if you go to your Schoology math class, you'll see all the work shown for every single question worked out there for you to study for this test. Okay, so on number 1, it says find the square roots, right? And we know we're going to have two answers, right? They're giving us two answer boxes. We also know we're going to have a positive and negative answer because of this plus minus before the square root, right? So I know I'm going to have one positive answer and one negative answer. And please, 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 you're going to see me do this. Please use your calculator on these, okay? So every calculator does it different. Make sure you know how to do that before the test. On your calculator, the square root of 2,500, the positive answer would be 50, right? There's my plus, and then the negative answer would be negative 50. Again, we have a negative answer because negative 50 times negative 50 would still give us that positive 2,500. On the next one, there's just one answer, right? When there's just a minus in front, I'm just going to get one negative answer. Okay, and so then I go second, square root 2.25, that's going to be a negative 1.5, okay? Let's scroll down here a little bit. On the next one, we're solving this equation on number 3. Okay, so we have x squared equals 100. I'm going to kind of rewrite this here. X squared equals 100. Okay, I draw my line. I want to get x by itself. Remember, we solve equations by doing opposite or inverse operations, and the opposite of squared, if you remember, is square root. It's got the same word in it, right? Square, square root. So when I do the square root of x squared, it cancels the squared, leaves me with x. What I do to one side, I do to the other. The square root of 100 will be 10. But remember, whenever you're solving equations, whenever you're solving for a variable with square root, you're always going to get two answers. Because 10 will work, 10 squared is 100, but negative 10 will also work, right? Negative 10 squared, negative 10 times negative 10 will also give me positive 100. You also see that there's two answer choices right there, okay? Plug those in, 10 and negative 10. Next one, number 4, looks kind of difficult with the fraction, right? It says take the square root of 49,576. Just square root both numbers, right? Square root of 49, that would be 7. And then the square root of 576 would be 24. So there's my answer. Square root of 49 is 7. Square root of 576 is 24. So just square root both numerator and denominator. Let's look at number 5. Number 5, I have another equation. I'm going to rewrite this. 4z squared equals 144. Before I do the square root, to undo the squared, I have to get that z squared all by itself, right? I have to isolate the variable. Well, that means I have to get rid of this 4. That 4 is connected by multiplication, so I do the opposite. I divide it out. Okay, so now I'm left with the z squared. You take 144 divided by 4 again. Use your calculator, double check to get an efficient, correct answer. Now I'm back to that, just like that equation we did above, right? The z squared is isolated. To get z by itself, do the opposite of squared, which is square root. That leaves me with just z. What I do to one side, I do to the other. Remember, when you're doing equations, you're going to get the positive answer, right? Square root of 36 is 6. But you're also going to get the negative answer, right? And that tells you you're going to have two answers right there. When you do cubed roots, again, make sure you know how to do those in your calculator. You're always going to only get one answer. If what's inside is negative, you're going to get one negative answer. If what's inside is positive, you get one positive answer. In this situation, what is on the inside is negative. So again, make sure you know how to do cubed root in your calculator. And the cubed root of a negative 125 would be negative 5. You're going to do the exact same thing on number 7. Again, I'll let you look at that one on the practice test answer key. To compare, on number 8, just find the square root of 64, find the cube root of 64, find out which one's bigger, okay? Let's look at number 9. do number 9 here. So number 9, another equation we're solving here. Again, we have to get the variable by itself. We need to get w cubed by itself. So the first thing I need to do is get rid of this minus 12 by doing the opposite. The opposite of minus is plus. So now I get w cubed, right? Negative 74 plus 12. You can do that in your calculator, or you can use our strategies. Different signs, find the difference. That would be a negative 64. Now I've isolated the variable, but this isn't squared, it's cubed. So again, we always do inverse or opposite operations. The inverse or opposite of cubed is cubed root, not square root, but cubed root. If I take the cubed root of w cubed, that cancels the cube, leaves me with w. What I do to one side, I do to the other. Remember, when you do cube roots, you only get one answer. If what's inside is negative, you get one negative answer, and then you just simply do the cube root of that negative 64 to find your one single answer of negative 4. Let's look at number 11. They want you to write 3 4/9 as a decimal. Well, the number that comes before the fraction is the whole number that comes before the decimal, so it's 3 point. Then just divide top by bottom, divide 4 by 9, right, to find out what your decimal is. When I divide 4 by 9, I get 0.4444, right, and it keeps going. And so remember, if that is a repeating decimal, you can use that bar notation, just like that. So 3.4 repeating. The bar notation says that 4 goes on forever. So your answer would be right there. So take a look at that. Let's look at number 12. I know that one can have a little bit of a longer process. 13 is just like what we did there. So to write this repeating decimal as a fraction, so it's 0.858585. So I would say it's 0.85 repeating. All right, here's our process. Set it up equal to x. Since two numbers are repeating, I'm going to multiply by 100. I'm going to multiply with 2 zeros. So 100 times x is 100x. 100 times 0.85 repeating, that just moves that decimal 2 spaces. That's 85.85 repeating. Okay, here comes our process. So at this point, I always subtract 1x from this side and subtract the original number from this side. So 100x minus 1x, that will give me 99x. That will cancel the 0.85 repeating. What happens over here is you'll cancel the repeating decimal and just leaves me with 85. Okay, almost there, one-step equation. Want to get x by itself, that's connected by multiplication, so I do the opposite, I divide. Always reduce fractions if you can. I cannot reduce 85/99, so that is my answer, 85/99. You can always double check to see if you did it right. Divide 85 by 99, and guess what you'll get? 0.858585 forever. Again, on this one, just divide the 1 by 6 to figure out what your decimal equivalent is on that. Check out that answer key. Same on 14. Again, on 15, you just want to make any fraction a decimal, divide numerator by denominator, divide top by bottom. When I divide 5 by 36, I get 0.13888888, and then it says 9 in your calculator. Understand it rounds that last number. That's not right. So really, it's 0.13 and the 8 is repeating. Again, only the 8's repeating, so the bar notation would just go over the 8. It would be this one right here. Be careful on that one. Those can be a little tricky. Just take your time. 16, we're talking about rational numbers, irrational numbers. So remember, irrational numbers are numbers that go on forever without a pattern. Rational numbers are either terminating decimals or repeating decimals. When I take the square root of 15, let's figure out what that is. The square root of 15 is approximately 3.87298, and then it just keeps going. And I don't see a pattern. So again, if I saw a pattern, I could stop and say that's a rational number. Any repeating decimal is a rational number. Anything that uses bar notation is a rational number. But numbers that go on forever without a pattern, like pi, are irrational. Again, it's irrational because it goes on forever and there is no pattern. The square root of 144. And your friend says that it is irrational. Well, the problem is when I take the square root of 144, I get an answer of just 12, the whole number 12. Well, that's a terminating decimal, right? Whole numbers are terminating decimals. Those are rational numbers. So do you think your friend's correct? No. And then you could say 12, right down in there, you could say 12 is a rational number, not irrational. Your friend's wrong. It happens. Define which one's greater, just decode both. Okay, let's do the last one, number 20. And I know you had another one up there like 20. It says, approximate negative square root of 105, and they want two answers. First to the nearest integer, then to the nearest tenth. Well, let's figure out, let's approximate what this is. Again, I'm going to get one negative answer. So square root 105, I get a negative 10.246, and then it keeps going, but that's all I'm going to need. The nearest integer, remember integers are positive or negative numbers with no decimals and no fractions. So the nearest integer, I'm just going to stop right there. Negative 10. No decimals, no fractions. The nearest tenth, remember the tenth is the first decimal place, so that'll go all the way to there, right? If you need to round, look to the right. 5 and above, give it a shove. 4 below, leave it alone. It's 4 below, so I leave that alone. That's just going to be negative 10.2. Look how you answer those two different ones. Nearest integer, nearest 10. All right, guys, please, please, please study this practice test. If you take it and turn it in and want a second opportunity, just email it to me and I can resend it to you. Again, all the work shown for every single question is in Schoology. It's in your math class in Schoology. Study, 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 and then take that test when you are ready in Big Ideas, the Chapter 9 test. All right, mathletes, first test of the year. Let's rock this. I know you can do it. Take care.